AP Calculus AB, Unit 9, Day 9, Office Hours. This is the pretest. You should have tried these all on your own and try to use this as sort of a practice run going towards your test. So we have some estimating definite integrals using either rectangles, Riemann sums of rectangles, and trapezoids are not called Riemann sums. Riemann sums can be right, left, or midpoint. We're going to use all the values in this table. I will draw a picture just to organize the information. And so we're doing trapezoids on this one. So we connect the tops with the secant line and you get a trapezoid. Down here, what are usually the bases of the rectangles are going to be the heights of the trapezoids. So the integral 1 to 6 of f of x dx is approximately, you got to show your work, area of the trapezoid is just the area of a rectangle, base times height. That's it. It's simple. Easy to remember, base times height. There's two bases, so we average the bases. 2 plus 11 divided by 2 times the height. 11 plus 7 divided by 2 times the height. So this is going to be 13 over 2, 39 halves. This is going to be 18 or 36 halves. And so then we get 75 halves. So the integral of 1 to 6 f of x dx is approximately, that's the symbol you should be using, 75 halves or 37 and a half. All right. I'm going to redraw this. 1, 4, 6. I'm not really trying to make this like perfect or anything, but I do like to try and make the heights just relatively correct. I don't know, I think that helps. Right endpoint means you're using the right side, so we're not going to use this one. And these are now the bases of the rectangles. So 1 to 6 of f of x dx is approximately base times height, 3 times 11, plus base times height, 2 times 7. So we can get 33 plus 14. And so the answer is the integral of f of x dx from 1 to 6 is approximately 47. Okay. All right, we got some more. These are going to be subdivisions of equal lengths, and I will tell you how many subdivisions on the problem, and then you got to make use of this whole table right here. The value behind this punch hole is 31. This one's 27. So I would just start drawing a picture. We're going 3 to 35, 3 to 35, two subdivisions. So that is 32, so it's going to be 16, that's going to be 19. But then we need, for this one, for midpoint, we need halfway between those. So 319 is 16, so it can be 11. And another 16, so add 8, it's going to be 27. And so 11 is going to be 7, and 27 is going to be 1. And these are going to be the heights of your rectangles. The bases are 16 each. So 3 to 35 f of x dx is approximately base 16 times height, 7, plus base times height, 16 times 1. So that's going to be 70, 112 plus 16. And so 3 to 35 of f of x dx is approximately 128. There you go. Next one. 3. In fact, we could actually, this is 4 subdivisions. That was only 2, but we had to cut our 2 in half, which would be exactly what 4 is going to be. So I'm going to just take advantage of that work I did. Otherwise, you'll go through the same process to get it. That, or you could say 335 3 to 35 is 32, divided by 4 is 8. So I'm going to go up 8 to 11, up 8 to 19, up 8 to 27, up 8 to 35. 3 is 10, 11 is 7, 19 is 2, 27 is 1, 35 is 7. These are left in, so we're not going to use this last right edge. The bases are all equal. They're all 8 this time. 3 to 35, f of x dx is approximately base times height, 8 times 10, 8 times 7, 8 times 2, 8 times 1. This is the kind of work I want to see to give you full credit and to help you, also for you to make less mistakes, but also if you make a mistake, that'll help me figure out what little, hopefully one single tiny mistake you made. I feel like I'm not going to try this in my head because I think it'll take me longer. That'd be 12, 20, carry the 2, 3, 8, 16, 160. So 3 to 35 of f of x dx is approximately 160. All right. One more with 4 subdivisions. So cool thing about that is we can use all of the values we wrote on the last one if you want. Otherwise, you got to go back and figure them out, which if they're different, you got to. This time we're going to connect these and do trapezoids. So these are the heights. The heights of all the trapezoids are 8. Those are the bases. So the integral of 3 to 35 of f of x dx is approximately average of the bases, 10 plus 7 over 2 times the height. Average of the bases, 7 plus 2 over 2 times the height. I'm going to go ahead and write these down here so I don't accidentally mess up. Plus average of the bases, 2 plus 1 over 2 times the height. And average of the bases, 1 plus 7 over 2 times the height. That's going to be a 4. That's going to be 4. That's going to be 4. That's going to be 4. So I'm going to get 4 times 17 is 68, plus 4 times 9 is 36, plus 4 times 3 is 12, plus 4 times 8 is 32. So 18, carry the 1, 8, 14. So the integral 3 to 35 of f of x dx is approximately 148. These should be straightforward problems, right? You just got to draw a picture. You just got to be careful. But you guys should hopefully get 100%. Don't lose any points on these. These are straightforward. Okay, next one says, if fx is increasing concave down, then which of these approximations yields an underestimate? I don't memorize this. I would draw a picture. So I'm going to draw a picture right over here where I have a little more room. So we have a function that's increasing and concave down. So really generic, going up, concave down. And I'm going to act like I'm going to do one slice because that should make it obvious. It should be true for as many slices as it is for one slice. So left end is over here. That's under. Right end is over. Right? Trapezoid is pretty obvious. That one's under. And I can just throw midpoint on here too. Midpoint is the hardest one. But the over part here is more than the under part, so it's going to be over. And it's true for left, it's true for one of these, and it's true for one of these, and the other way it goes the other way. But left, right, and trapezoid are pretty obvious just from a quick sketch. No need to memorize it. So your answer is going to be left end and trap. Draw sketch. Okay, next one is definite integrals. Now, be careful. I know we've been doing a lot of integrals of absolute values, but these are not absolute values. These are just some more integration, but with definite integrals, which we didn't do a lot of last chapter. We started doing them. We were focused more on just indefinite integrals. So, but these should be, not too bad. Just integrate them. No absolute values. Show your work. Plug 6 in, 36 plus 72 minus 9 minus 9. That's going to be 0. So we're going to get 108 or 108. Oops, I think I made a mistake. Plug 3 in here. It's going to be 9 minus 27. I think that one's going to be 9 too. Oh, it's supposed to be a plus. I just kind of was instinctively doing the minus, which is here. So that's not going to be, that's going to be 18. So your answer is going to be 90. Now, if you made that one mistake, that would have been one mistake. Everything else made sense with it. Your answer fit your work, then you'd be penalized very lightly. Okay, this one. Here, we could do u substitution. U equals 2x. D equals 2dx. Done with the 2. Here's a couple issues here. One, we could probably avoid u substitution. 2, if we're going to do u substitution for this, don't do it for this. This one doesn't need it. There is a way that you can incorporate this and make it work, but you're not going to do it. It's gonna be extra hard, and you're going to probably mess it up in a way that costs you a lot more points. So really, we should be integrating this guy on its own, right? And then integrating this guy on its own. Now, you could do the whole u substitution thing, but only do it for this guy. Okay, leave this stuff as all x and stuff. The 1/2 doesn't affect this. It only affects this. So we're going to get 8x squared over 2. And by the way, I'm just telling you, like, this is going to, I could have jumped from here to what we get. The antiderivative is going to be cosine 2x for sure. It's going to have a negative. And an extra 2 is going to pop out that I don't want, so I need 1/2. Boom. Without going through all this. But if you kept going, you get negative 1/2 cosine u, and then you would have to plug it back into u. So you could skip all of this and just go directly here if you feel comfortable. If it's just a constant, then I don't, if it's just an extra number that's going to pop out because of chain rule, I can totally deal with that without doing all this. But if you can't, then you should do this. Get it right. That's what's important here. So this is going to be 4 times pi squared over 4 minus 4 times 0 squared plus negative 1/2 cosine of pi minus 1/2 cosine of 0. Cosine 0 is 1. Cosine of pi is negative 1. So this is going to be pi squared. This is going to be positive 1/2. And this is going to be positive 1/2. So that's going to end up being 1. All right, get those right. We've been practicing those for a long time. Nothing super fancy there. Now here's some more of the new stuff. Integrals of absolute values. And you have options here. I'm going to actually go ahead and show you how to do number 6 3 different ways. Number 7 and number 8, 2 different ways. Okay, so you get all of these, you could do kind of the same basic straightforward approach, or you could do the table, which is kind of a shortcut for any of these. If it's linear, then you could do geometry, where you draw a picture of the graph, which maybe you don't want to do that, but in the end, it's effective. It might seem easier. Okay, so up 1 over 1, 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 up 1 over 1. The absolute value flips the negative part up, makes it positive. Positive part stays positive. We're doing 1 to 7, so it's 3, 4, 5, 6, 7. and it's two triangles. So you can say, all right, it's a triangle and a triangle. Not that you have to write this, but if that helps. And then 1/2 base times height, 1/2 base times height. Again, you don't have to write this. The base of the first one is 3, and the height is 3. The base of the next one is 4. The height is, now be careful, the slope is 1. So if we go over 4, that means we went up 4 also. So if you're going to do geometry, make sure you get these measurements right. So that's going to be 9 halves plus 8, which would be 16 halves. So 25 halves, or 12.5. So that's one way you could do this problem. And of these problems on this page, it's the only one that you could do like that, because the other ones aren't linear. But we could also do the table instead. So the table is, okay, find the 0. Don't necessarily need to do a line check. On number 8, I'm probably going to do a line check even with the table, because we're going to get weird irrational values, possibly. So the table is, we're going to integrate x minus 3 without the absolute values. That's the whole point of this, is to get rid of the absolute values. So if you still have absolute values here, it doesn't quite make sense. X squared over 2 minus 3x plus c. Don't really need the c. Endpoints are 1, 3, and 7. Plug 1 in, you get 1/2 minus 3, which would be negative 5 halves. Plug 3 in, you get 9 halves minus 9, which would be 18 halves, would be negative 9 halves. Plug 7 in, you get 49 halves minus 21, which would be 42 halves. That would be 7 halves. And we find the distance between these from negative 5 halves to negative 9 halves is positive 4 halves, or 2. From negative 9 halves to 7 halves is going to be 16 halves, or 8. And you add those together. Oh, shoot. Okay, 1 second. So I should get the same answer. So I'm trying to figure out what I did wrong. The answer here is 10, which, if I check my answers with my solutions, that is the correct answer. So where did we mess up over here? Oh, shoot. Simplest mistake. We're supposed to start at 1. This is supposed to be the area right here. And so the base is 2 and the height is 2. Oh. So this is 2, and then we get 10. Wow. Yeah, I just wasn't patient. I just automatically started at the y-axis. Okay. The other way is to find the 0 and do a quick line check. X equals 4, positive, negative. And then we break up the integral. We say, okay, let's go 1 to 3, drop the absolute values. And let's go 3 to 7, drop the absolute values. And if it's negative, we got to fix it with a negative in front. If it's positive, leave it positive. And now we're just going to go ahead and do these definite integrals, which, it's a bit of work, a little redundant work. So x squared over 2 minus 3x, which you'll notice is the same thing we're getting in the table approach, right? X squared minus 3x, but we just did it once. So here we're going to have to do it twice. X squared over 2 minus 3x, which isn't terrible. You know they're the same. But then we're going to have to plug 3 in twice. So negative, this is going to be 9 halves minus 9 minus 1/2 minus 3. And then that's going to be 49 halves minus 21 minus 9 halves minus 9. This is going to be, I'm going to make it a least common denominator. So, well, I think I can avoid that. I'm going to avoid that. I'm going to say, okay, well, 9 halves minus 1/2 is 8 halves. And negative 9 plus 3 is negative 6. And remember, this better come out positive. So I almost lost my negative just now. I was like, what? That's wrong. That's going to be negative. So it's going to be 8 halves minus 12 halves is negative 4 halves is positive 2. And this one's going to be 49 halves minus 9 halves is 40 halves. And it's going to be minus 21 plus 9 is negative 12. That's going to be 20 minus 12 is 8. And we get the same answer. So here you go. Here's your 3 different ways of doing the same problem. You choose which amount of work, which type of work you like better. Can't do the graph approach on this one because it's not linear. So we're going to find the zeros. And then for the table, we could probably get away without doing the line check for the table. Ones with trig, ones that have irrational answers, I think I might need the table just to make it a little more. So the table, you say, okay, well, 0 to 6 x, we're going to integrate x squared minus 2x without absolute values. We're going to get x cubed over 3 minus x squared plus c. I'm doing the 2 divided by 2 cancels out in my head. At some point, hopefully you feel comfortable with that. This is going to be 0. It's going to be 8 halves minus 4, which is going to be negative, which is 4 minus 4, which is 0. It's kind of crazy. I feel like I made a mistake. What did I do? X cubed. Did I go too fast? Oh, over 3. This is going to be 8 thirds. So minus 12 thirds is negative 4 thirds. Okay. I mean, it's weird to get a bunch of zeros. 6 is going to be 6 times 6 is 36 times another 2 is 72 minus 36 is 36, or 108 thirds if you want to do that. And we're going to find the distance between these, which is 4 thirds, and this would be 112 thirds. And so together, it's going to be 116 thirds. 3 goes into this, 38 and 2 thirds. You can leave it 116 thirds. That's totally fine. So there's that approach. And then there's the other approach where we would do a line check. And positive, negative, positive. So then we would rewrite it. We'd say, okay, integral from 0 to 2, x squared minus 2x dx. Integral from 2 to 6, x squared minus 2x dx. Any negative parts got to be fixed with extra negative in front. That's going to be positive. And so then we're going to get negative x cubed over 3 minus 2x squared over 2, 0 to 2, plus same antiderivative, x cubed over 3 minus x squared, 2 to 6. And then we're going to plug 2 in, so that's going to be 8 thirds minus 4 minus 0 minus 0. Plus 6 is going to be 72 minus 36 minus 8 thirds minus 4. And so least common denominator, 3, so this is going to be negative 4 thirds. 8 minus 12 is negative 4 thirds. So it's going to end up positive 4 thirds. Better be positive. This is going to be 36, and this is going to be negative 4 thirds. That'll become positive. So we could do least common denominator. 108 plus 4 is 112 thirds. So we get 116 thirds, which is fine, or 38 and 2 thirds. I think the table, kind of really pays off. I mean, you should know how to do this, because if it's been a month and you haven't done the table and you don't really remember it, then you're stuck. You better know how to do it the long way and realize that the table is just streamlining it, and take advantage of it if you understand, but always be able to fall back on the most normal approach. This one, I'm going to set this equal to 0. no matter what approach we take. And we say, okay, well, alpha equals pi over 6, quadrants 1 and 2. So we want x equals pi over 6 plus 2 pi k. All our basic trig stuff come back in practice. X equals 5 pi over 6 plus 2 pi k. We only want the values from 0 to 2 pi, so that's just going to be pi over 6. Okay. Now, I think I need to do a line check even for the table here, because I think that's going to be the easier approach. You don't have to, but I think that's going to be the easier approach. And it's not terrible. Sine of 0, 0, that's going to be negative, positive. So in the table, we get negative 2 cosine x minus x plus c. We're going to do 0, pi over 6, pi over 2. We're going to plug these in here. So negative cosine of 0 is 1, so that's negative 2. Minus 0 is negative 2. Pi over 6, cosine of pi over 6 is root 3 over 2. So you get negative root 3 minus pi over 6. Pi over 2, cosine of pi over 2 is 0, so we're just going to get negative pi over 2. Now, trying to find the distance between these, if they're just numbers, I feel confident that I can, almost without even thinking of it, make sure I get the positive difference between them. But these ones, I'm like, well, is this bigger than this, or is that bigger than that? And what I could do is estimate these and try and figure out which one's bigger than the other, make sure I subtract the right way. But this is where the line check can really make it easy. Generally, we do the upper limit minus the lower limit if the function is above the x-axis. But if it's below, it's negative, and we want it to force it to become positive, we can go backwards. So for the negative part, I should go backwards. I should do this one minus this one. And then for sure I know that this should be a positive answer. If I went the other way, I'd get negative and maybe not even realize it, unless I did a bunch of extra work. This one is normal, it's positive, so I'm going to go upper limit, later number, minus the earlier one. And then we're going to add these together. So we're going to get 2 root 3 minus 2, and then we have 2 pi over 6 minus 3 pi over 6, so it's going to be minus pi over 6. And this should come out to a positive number if you were to put it in a calculator. So that's the way I do it. I think line check pays off on these weird irrational answer trig ones. Otherwise, we could do all that work that we just did and then split it up and say, okay, we're going to do 0 to pi over 6 of 2 sine x minus 1 dx. And we're going to do pi over 6, pi over 2 of 2 sine x minus 1 dx. Drop the absolute values. That's the whole point of this. Fix the negative one with an extra negative in front. And then get to work. The antiderivative is going to be negative 2 cosine x minus x. Same antiderivative, negative 2 cosine x minus x. So we're doing the same work as in the table. Like we had to integrate that, but we just did it once here instead of doing it twice. So that's one of the little time savings of the table. And then we're going to plug pi over 6 in twice. Here we just did it once. Now the one benefit to this is then you don't have to overthink, well, which way should I subtract it? It's already built in correctly. So if I plug pi over 6 in, that's going to be root 3 over 2, so it's going to be negative root 3 minus pi over 6. If I plug 0 in, it's 1, so it's going to be negative 2 minus 0. And then I plug pi over 2 in, and that's going to be 0 minus, and plug pi over 6 in, that's going to be root 3 over 2, it's going to be negative root 3 minus pi over 6. So now we just got to keep going. This is going to be positive root 3 plus pi over 6 minus 2. So that's the first one, which if you look right here, that's the same as what we got. And this time we didn't have to decide which way to subtract it. It was already set up correctly. This is going to be plus root 3 pi over 6. This is going to be positive pi over 6, negative 3 pi over 6. I mean negative 2 pi over 6, which I'm going to leave like that so I can combine easier with the next step. So now it's 2 root 3 minus 2 minus pi over 6. Same answer, but I don't know. You decide. You only have to do it one way. I'm just doing it both ways just to give you guys that extra support. So next problem is, it makes you maybe think of the fundamental theorem of calculus problems I gave you, but this is not the graph of the derivative. We're not trying to integrate the graph of the derivative. We're just using this to find answers. So negative 4 to 2, we're going to look at the area now. If it's below the x-axis, it has to be negative. So that's half a circle, half pi r squared, but it's going to be negative. And then 1/2 base times height for the triangle. So it's going to be negative 1/2 pi. The radius is 2, never negative. So that's going to be 2 squared plus 1/2. The base of the triangle is 2. The height is 2. So we're going to get negative 2 pi plus 2. Now, we can get negative answers. We're not trying to do distance here, so, or whatever. So it's okay to get negatives. Okay, next one is negative 2 to 3. So that's going to be a negative quarter of a circle. Plus, you could do a triangle and a rectangle, or you could do a trapezoid. Trapezoid would be average of the bases, which would be 3 and 1. 3 plus 1 over 2 times the height, which would be 2. Or you could do a triangle and a rectangle. You get this triangle that we got in the last one. So negative 1/4 pi, the radius is 2 squared plus 4. This is going to be negative pi plus 4. Okay, next one, 1 to 5. 1 to 5. You could do a trapezoid, or if you want to get more complicated, you do a big triangle minus a little triangle, get that. And then this is a big rectangle. So the trapezoid is going to be average of the bases, which are sideways this time. Using this slope, the slope should be constant, so that should be 1. It's 1 plus 2 over 2 times the height, which is down here at the bottom, 1. And then the area of this rectangle is going to be, the base is 3 and the height is 2. So that's going to be 3/2 plus 6, which is going to be 15/2, or 7.5. Okay, last one. Now, on this one, what I would do is I would, we've done this a lot, I'd break this up. You have to integrate the 3, though, still on its own. And so this is going to be 2 times. We've got to find the integral from negative 4 all the way to 6. So that's going to be the negative half circle, negative 1/2 pi r squared. It's going to be the triangle, or you could do one big trapezoid. That'd be cool. Or you could do one triangle and a big rectangle. The trapezoid would be, the bases would be 6 and 4, 6 plus 4, and the height would be 2. Okay, and then this guy on its own, this one doesn't even use the graph at all. So we could either integrate it, find the antiderivative, because we actually have a function, and do it that way, or you could imagine that's just a flat line and take a geometric approach, going from negative 4 to 6, and we're just trying to find the area of that rectangle, and that's going to be 10 times 3 is 30. Now, if you do it like this, you're going to get the same answer. This is going to be 2 times negative 2 pi plus 10. And then here, if we kept going with this approach, it would be 3 times 6 minus 3 times negative 4. And so we get negative 4 pi plus 20. This is going to be 18 plus 12 is 30. So your final answer is going to be negative 4 pi plus 50. Okay, so that's just some extra practice with definite integrals from a graph. Okay, we're also going to have distance and displacement problems. Using some of our new stuff here. So, the position values of Johnny's truck and number one include the endpoints, turning points are given. Find Johnny's displacement. Well, using the table is super easy with displacement. It's the integral of velocity from 0 to 15, which is going to end up being position 15 minus position 0, which from the table is negative 2 minus 10 is negative 12. The distance is the integral of the absolute value of the velocity, dt, 0 to 15. And what we would do is we do the integral of velocity dt, and you would get position. So that's already been done for us. We just need to find the distance between these, which would be 2, 4, 1, and 11, and add them up. That'd be 6, 7, 18. So that was kind of a quick little warm-up problem, because usually we have to do that work ourselves. So next problem, we're going to have to do more ourselves. So here's acceleration. We need the velocity function. So we're going to do a little old-fashioned work and say, okay, well, velocity is going to be the integral of v prime, which is the integral of acceleration, dt, which is the integral of 12t minus 18 dt. And so then vt equals 12t squared over 2 minus 18t plus c. We've got to find the c value. We have the initial condition here. I don't think we need to find the position function. I mean, that's one way to do it, but 6 times 0 squared minus 18 times 0 plus c equals 12. C equals 12. So the velocity equation is 6t squared minus 18t plus 12. So for displacement, we would integrate the velocity and go from 0 to 3. But I'm going to make a table. I think the table is the way to go here. So if we just do the table approach, we can do that for both of these problems. We can use the same table for both these problems. So it's going to be the integral of velocity without the absolute values. So that's the integral of 6t squared minus 18t plus 12 dt. And that's going to be 6t cubed over 3 minus 18t squared over 2 plus 12t plus c. Let's zoom out a little bit. Okay, now we do need to do one more thing. We got to find the turning points. So we need to factor that. So we're going to factor a 6 out and set equals 0. T minus 1, t minus 2. And so we get t equals 1 and 2. Those are turning points. So we need to do 0, 1, 2, 3. So we're going to plug these in here. We're going to get 0 for the first one. And 2 minus 9 is negative 7 plus 12 is 5. And then 2 would be 2 times 8 is 16 minus 36 plus 24 is going to be 4. We plug 3 in, it's going to be 2 times 27 is going to be 54 minus 81 plus 36. So that's going to be what? 90 minus 81 is 9. So displacement, you're just going to do 9 minus 0. Distance, you're going to find the distance between all of these and add them all up. And distance equals 11. So with that table, we could do all that. Now, if you don't want to use the table, you're going to do all the work we just did before the table. And then you're going to, then you're going to do 0 to 3 of the integral of 6t squared minus 18t plus 12 dt. You're going to do all that work to get displacement. And then over here, you're going to do the integral of the absolute value of velocity, absolute value of speed. And so you're going to have to do 6t squared minus 18t plus 12. You're going to have to do a line check now with your turning points to figure out where to split it up. So you would say, okay, well, it's going to be 1 and 2. We're going to test the value. Time equals 3. Plug it into velocity. The factor version would be the easiest way to figure out that it's going to be positive, negative, positive. So you're going to have to go, okay, we're going to have to go 0 to 1. And then we're going to have to go 1 to 2. This is the problem with the table really pays up. Then we have to go 2 to 3. I'm not going to finish this. I'm just setting it up for you if you really want to do it that way. The negative parts have to be fixed. So this is positive. This is negative. So we need an extra negative. And now you have to keep going with this. So mean value theorem was also a new idea from this chapter. So average value means mean value. Mean is a fancy word for average. So the idea that we learned is that if you take a curve, I'm going to redraw. This is what you should be picturing in your head. And you're like, well, I want the average from here to here, which would be like somewhere around there. The strategy is to find the area under the curve, smooth it out as a rectangle. The height of that rectangle is your average height. So then you just divide by the base. So F average is you find the area under the curve from 0 to 10. And imagine it's been smoothed out as a rectangle. Divide by the base of the rectangle, which is the difference in limits. Better be positive. Right minus left, big minus small. And then that's it. So I don't memorize that as a formula. I think it through each time, which I guarantee is going to be more effective because I was screwing it up when I wasn't doing that. When I tried to memorize it, I mess up all the time. So now we just got to do the work. And so that's going to be, 1,000 over 4 is 250 minus 3 times, or actually 10 squared. That's 10,000 divided by 4 is 2,500. This is 1,000, so that's going to be 3,000. Excuse me. Minus 0. So it's going to be negative 500 over 10. So it's going to be negative 50 for F average. Did I make a mistake somewhere? Oh my gosh. There's another 8x there. So that's going to be plus 8x squared over 2. I just totally missed a term there. So there should be another plus 400 here. And then this is going to be negative 100, which is going to be negative 10. I just missed that. Okay, x star is the same thing as the c value. That's the guarantee by the mean value theorem that the actual function will equal the average value at least once. Very similar to the derivative version. But this is for this one. So we got to find the average value first. So f average equals, we got to integrate the function, find the area underneath it, smooth it out as a rectangle, divide by the base of the rectangle. Also, by the way, doing it this way guarantees going to stick in your head longer. If you just try and memorize it, you're going to totally forget it later on, even if you effectively memorize it. All right, so negative cosine of 4 pi is 1, so that's going to be negative 1 plus 4 pi minus cosine of 0 is not 0, it's 1. So it's going to be another negative 1 plus 0. So that's going to become positive 1, which is going to cancel the negative 1. So this actually works out really nice. It's going to be 4 pi over 4 pi is 1. So that's the F average value. Now be careful and remember that that's not what they asked you for, but we need it. We want to find the C or X star value. I don't care what you call it. So we take the original function and we set it equal to the average value. And then we solve. So this is going to be sine x equals 0. So that's going to be x equals 0 plus pi k. I only want the values between the endpoints and including the endpoints here. 0, pi, 2 pi, 3 pi, and 4 pi. It's at least once, but there could be more than one, and you need to find all of them. So x star or C, whatever you want to call it. Okay. Average value of this. Now, this is an interesting problem, and I'm telling you, you might have a problem like this on the test. To find the average value, let's just set it up. Average value generically is going to be the integral of the function between the endpoints, 0 to whatever that is, and divided by the base. And if it's a piecewise function, you got to find the total area and divide it once. Sometimes people are like, oh, I'm going to find the average of this and average of this, add them together. That doesn't work, okay? So we got a couple issues here. One, we got to find the integral of the whole area, region R. So let's just start with that. Now we got to find this x-intercept, I guess, which we get pretty easily by saying this is 0. So this is 12, 0. They gave us this intersection, which we could have had to find ourselves. So let's just practice that real quick, just in case. Square both sides. X equals x squared minus 24x plus 144. 0 equals x squared minus 25x plus 144. 0 equals, we'll try and factor it. Hopefully we can factor it. Two numbers will multiply, you get 144, but add together you get 25. They've got to both be negative. But, and I think they kind of tipped us off right here. 9 is one of them. 9 times 16 is 144. So you get x equals 9 and 16. Now, which one is it? Now, remember, this graph would keep going, and this is the 16 down here, okay? This is the 9. So you might have to think a little bit. Okay, anyways, if you had to, you could do that. This is 0, 0. This is just where the sideways parabola has an x-intercept. We can set this equal to 0 and solve for x, solve for y, solve for x, x equals 0. Okay, so we got that. So we got to break this up and do these two separately. So we're going to do the integral of the function 0 to 12. Because it's piecewise, we have to do 0 to 9 of the square root of x. And then we got to do 9 to 12 of negative x plus 12. Got to do them separately. So that's going to be x to the 3 halves, divided by the new exponent. And this is going to be negative x squared over 2 plus 12x. And so this is going to be, square root of 9 is 3. Cube is 27 divided by 3 is 9. So that's going to be 18 minus 0. Negative 144 is going to be negative 72 plus 144. And then we got to plug in 9, which is going to be negative 81 over 2 plus 108. I'm just finding this area is annoying. Okay. So this is going to be 72. This is going to be 216 minus 81. 19. 135. 135 halves. So this is going to be 90 now. And so it'd be 180 halves. And we're going to subtract this one. So it's going to be 180 halves minus 135 halves is 45 halves. So that's That's just the integral of f of x. Okay, that's just the area of region R. So to get f average, I mean, that's the hard part. We're going to do 1 over 12 minus 0 of that. But it's got to be the combined thing. You can't do them. You can't do the f averages separately. You can find the area separately, add them together to get the total area, but then you got to do it as like one big area. So it's going to be 45 over 24, which we could divide a 3 out and be 15 over 8. So that's f average. Now, just as an extra question, which is one doesn't ask, what if I asked you for the c values? Now, 15 halves is what? Almost 2. So it's kind of like around here. And you could visualize that we should get one here and we should get one here. So we should get two c values where the actual value of the function equals the average value of the function. The way we're going to do it, though, with piecewise, it gets a little more complicated. To find this one, you got to set the square root of x equal to 15/8 and solve. Okay? And then the answer you get better be between 0 and 9. Otherwise, it doesn't make sense. And then you shoot. And you might get extra answers sometimes. The other one, you got to set the other piecewise function equal to the average value to get this one. So you're going to deal with each piece at a time to figure out where it intersects that. And then this would give you an answer. And these would be your c values. So you got to put it all together to find one average value. To find the c values, you might have to attack them separately. Okay. Last page. These are quicker problems. So we got fundamental theorem calculus part 1. So if I just give you the derivative value, give you the integral of the derivative, and give you another function, I want to find that. Fundamental theorem of calculus says if you integrate the derivative, you get the original function. And if you have limits, you plug the limits in. So we're going to be using that on 18, 19, 20, ABC, 21, 22. We can use that approach on all of these with slightly different ways of getting the information. So if I integrate f prime of x dx from 2 to 7, you want to use the value that you know and the value you want, but smallest to biggest. You get f of 7 minus f of 2. This is work you need to show. You want f of 2, so you're going to add it over here. Subtract that back over. To me, this is critical of knowing that you know how to do the calculus. Then we're going to plug the values in. f of 7 is 20. This integral I just gave you was 9. So f of 2 equals 11. So that's how we're going to do these. This one right here, this is the capital F. Capital F equals the, no, I think the derivative, yeah. The derivative of capital F equals little f. So I probably won't do this to you, but this is the same thing as f prime in here. Okay, so if we integrate f prime of x dx, we should get the original function. Let's use 2 and 9. So we're going to get f of 9 minus f of 2. I want f of 2, so I'm going to add it to the other side and subtract this back over there. So it's good to show your approach. And then you're just going to plug the values in, and hopefully you plug them in correctly. But if I don't see your approach and you plug them in wrong, for sure, I don't know what. I can't. It's hard for me to give you credit. So that's that. And then this next one. Now, I think what I need to do is I'm going to go ahead and break up this video because I think I have a little too much, and I'm scared that the memory is going to become an issue. Usually when I approach around an hour, I have issues. So I'm going to stop this video and do a smaller one.